Today we're going to look at finding the distance between 2 points. And we see here point A and point B. The distance isn't from A up to this point and from B over to that point. The distance here is the shortest distance between A and B. It is the same as the hypotenuse of this right triangle here. And here we can see to find the distance between P and R, I can make use of the Pythagorean theorem. The difference between P and Q is 12. If I count the little marks, I'll get 12. The distance between Q and R is 5. If I count the little marks, I'll get 5. The other thing I could do is subtract the x values and subtract the y values. Then I can set up an a squared plus b squared equals c squared, which is what we're going to see here. A squared plus b squared equals c squared. They've just gone ahead and taken the square root of both sides to solve for c. What we figured out is that using the Pythagorean theorem, the distance from P to R is 13. Now, the distance formula is actually just a sneaky way of using a squared plus b squared equals c squared. The difference of my x values, that's how we found our PQ length. That's x2 minus x1. The difference of my y values, that's how I found my y length or my b length. And then, of course, we square those, a squared plus b squared. And to find c, we have to take the square root. So the distance formula is nothing more than the square root of c, or the square root of c squared, in terms of the Pythagorean theorem. So here's an example using the same numbers. So we can use the Pythagorean theorem, but if we use the distance formula, it would need to be set up this way. 3 minus a negative 8 is 11. 11 squared is 121. Negative 2 minus 4, that's negative 6. And when you square it, it's positive 36. So we get 157. And that's all I have today.